Okay, today we want to talk about the HABER process. This is an IGCSE um, uh, topic. So for those that are doing IGCSE, this will be helpful. But before you do this, you must have prior knowledge of what is a reversible reaction and all the conditions that go and the factors that go with reversible reactions. So it will be good for somebody to go over this reversible reaction thing. But the HABER process. So what is the HABER process about? So the HABER process is about the manufacture. It is about the manufacture of ammonia. This is the manufacture of ammonia. Right. So what do we mean by the manufacture of ammonia? So in the manufacture of ammonia, why manufacture of ammonia? Why is it important? Ammonia, well, ammonia is important for, it is used actually, it is used, let me remove this and say it is used, it is used for the making or for making ammonium sulfate and ammonium nitrate and these two are important in agriculture really because they are actually fertilizers. They are fertilizers, so they are important. Actually, this is used in many. Ammonia is used in other things like TNT and stuff like that, and detergent, and all those other things, or all those funky things. But fertilizer is one of the things that it is used for. So it is good to talk about fertilizers, especially in this age where we have got food shortages. Right. So moving on. So how is ammonia made? What is the process? The process of making ammonia. So what happens? Obviously, we need to start from the reaction. What happens is that you need hydrogen to react with nitrogen gas, and this is going to give you, rather, this is going to give you a reversible reaction. This is going to be a reversible reaction, and it is going to give you ammonia, which is actually a gas, and we need to balance this equation, and this is how it is balanced. And this reaction is actually exothermic, which means that delta H is actually less than 0. Now, having said that, what happens? Where do we get hydrogen from? Hydrogen is actually we get the hydrogen, the source of hydrogen, from the cracking of crude oil. This is actually in the topics that are in the future, but at the moment you just need to know it is made from the cracking of crude oil. And where do we get nitrogen from? Nitrogen, we obtain it from air, right? But what happens is that air is liquefied. And when the air has been liquefied, the components of the air and components of the liquefied air are separated by fractional distillation. Okay, so that's what actually happens when you that's what you get that's how you that's where you get the raw materials, these which are nitrogen and hydrogen. Okay, so you just need to know that, because in exam questions are going to be asked about what is the source or where do you get the raw materials from. If they ask you about hydrogen, you just say you get it from the cracking of crude oil. Of crude oil. I don't know what I'd written there, but that is what it is. So it is the cracking of crude oil, and the nitrogen, you're going to get it from the liquefaction of air. So moving on quickly. So let's talk about the manufacturing process itself, right? Let's think about this. What happens if we I need to change this color, is not very clear, to blue. Okay, so what happens if we use we have to think of temperature because it is a reversible reaction, right? So what happens if we have got a high temperature? If the temperature is high, what's gonna happen, right? Now, well, what's gonna happen is as follows. At high temperature, what happens is that you are going to have the rate of the forward reaction and the backward reaction will increase. Well, why does it increase? It increases because you have more collisions. We have more collisions because there is more kinetic energy, and therefore there is going to be more collisions, and these collisions will result in more in the rate increasing, so you will have a high rate. So what is going to happen? We have got a high rate, so that is the thing that is going to happen. We are going to affect the rate of the reaction. All right, so what happens if what happens to therefore the yield? What happens to the yield, right? Well, what happened? We already know that high temperature favors the endothermic reaction. Endothermic reaction. And we already know that we already know that the forward reaction is actually exothermic, and therefore it means that if the forward reaction is exothermic, it means that the backward reaction is endothermic. So what happens is that we are going to favor the backward reaction, and as a result it means that the yield is going to decrease. Therefore it means that yield is going to decrease. Is going to decrease. High temperature reduces yield, in other words, but it has got an advantage that it increases the rate of the reaction. So what do we need therefore? What we are going to need is that if we make the temperature too high, we are going to lower the yield, but we are going to increase the rate. So we need a temperature uh, that is okay, not a temperature that is too high or a temperature that is too low. Why? Because a low temperature will favor the forward reaction, but what will happen is that a low temperature will decrease the rate, right? Because there will be fewer collisions, and at the end of the day, what is going to happen is that your yield increases, rate decreases, so it's going to take too long to produce the high yield at the end of the day. So you need a compromise. You need a temperature that is okay. So uh, low temperatures reduce rate but increase the yield, right? So we are actually caught between a hard place and a rock. So what do we need to do? We need a temperature that is okay, and that temperature that is needed is actually 450 degrees Celsius, which is the uh, okay temperature that we were talking about. So 450 degrees Celsius. So, well, what is the other thing that we are going to need for this reaction? We're going to need air. Another thing that we will need is a catalyst. And right, we already, when talking of a catalyst, the catalyst that is normally used for this process is actually an ion catalyst. And the ion catalyst should be very fine, so it should be nearly powder. So why do we make it powder? To increase the surface um, area. You already know that the function of a catalyst, is to increase the rate of a reaction. So let's look at the let's look at it graphically, right? If we look at the catalyst graphically, what we are going to realize is that this obviously this is going to be your energy, and this is going to be your reaction pathway, right? And obviously we already know that our reaction is actually endothermic, right? So what do we know? So because it is endothermic, it means that the energy of the reactants is higher than the energy of the products. So these will be your reactants, and this is your products. So what will happen is that if so, yeah, right. And what happens is that you obviously will need this, which we already know is your, let me just remove that and do that. This is your EA. Your EA is actually your activation energy. Remember, catalyst is, you remember that the EA, it is the energy that is needed for a reaction to start. Okay, now what happens now? If you put a catalyst, what is going to happen? You are going to have a different reaction pathway, which means that it lowers your EA. So this will be, this is your EA without a catalyst, and this is your EA with a catalyst. So this is your EA with a catalyst. Okay, so, but what you're going to realize is that when you put a catalyst, what is going to happen is that the rate, what what happens to the rate? This means that the forward reaction pathway is going to also to be shorter, but the backward reaction is also going to be shorter. So it means that the what happens is that the rate, if we look at the rate, what happens with the catalyst, it means that the rate of the forward reaction, the rate of the forward reaction and the backward reaction will increase. So both the rates are going to increase, but this is not going to really affect the yield. It's only the rate that is going to be increased, but the rate of both the forward and the backward reactions are going to increase. Yield will remain the same. So remember, your catalyst must be must have a low must have a high surface area, and also that it increases the rate of the reaction. And now the other thing that is important that we need to talk about is actually the pressure. We need to think of pressure. So talking about pressure, we have got to remember that we have got to look at the states of these things, right? We know that they are all gas, and since they are all gas, what happens is that we need to be able to this should be hydrogen. Okay, so what happens is that we already know that in an increase in pressure, we should know that an increase in pressure favors the side with few gas molecules, and it's only gases that are affected. In this case, we've got to count the number of gas molecules that are in the reactants, and in the reactants we have got 4 gas molecules. We've got 4 molecules, and here we have got 2 gas moles. We've got 2 gas moles, 2 moles. Right, so it means in the reactant, so it means that the forward reaction is therefore going to be favored because we have fewer gas. We have got fewer gas moles, which means that yield is going to increase. Yield increases. Right, and the other thing that we need to talk about is rate. What happens to the rate? So what happens is that because what happens to the rate is going to also increase, and the rate of the backward reaction, both the backward reaction and the forward reactions are going to increase. Both of the rates are going to increase, and this is very important for us to be able to actually mention and notice. So what are we saying at the end of the day? This we need to know the following things so that we summarize. Right, now looking at the summary, what happens is that we need a temperature of 450 degrees Celsius, right? This temperature is an okay temperature. It is okay that is not too high or not too low, right? And we know that this temperature is the best temperature, because if we increase the temperature, if we make it too high, what happens is that the rate is going to increase, but the yield is going to decrease. And also we are going to need a catalyst, and the catalyst is actually iron, right? And why do we use a catalyst? A catalyst will increase the rate of the reaction and increases the rate of the backward reaction, the forward reaction. And we are also going to need a pressure, and I've forgot to mention the pressure that is needed. The amount of pressure that is needed is actually 200 atmospheres. Right, you need to learn this, and this is the pressure is actually 200 atmospheres. Why do we use 200 atmospheres? Because it increases the rate but also increases the yield. Right, so this is it, guys. As far as the video for today is concerned, and you need to learn this about the HABER process, and meet you in the next video. All right, thank you.